two data columns, 1 and 2, and we are going to go and have a look, first of all, visually. Doc, insert, not a graph, but a data and statistics, which plots the points. Your particular drop-down menu may not be as complicated as this, and you just go and find the variables. Now, before we had x and y, but I think I called them 1 and 2, so 1 on the x, and here I think we called it 2 on the y. All right, test 1 and test 2. Beautiful, right? So you can see visually it's linear correlation. Now, all the tools I'm going to show you now really apply to linear correlation and linear models. Right, so that's an important thing. We're going to talk about the R value. We're going to talk about the R squared value, the coefficient of determination. We're going to talk about SSres and SStot, the sum of the square residuals and the sum of the square totals. So all of that coming. Now, first of all, we'll go straight on here. Menu, analyze, regression, and we're going linear regression, and there it is. So you get the line of best fit straight away from this particular page. But you can also get that line, that line of best fit from the previous page. So on the spreadsheet page, menu, statistics, stat calc, and there's also linear regression. And the benefit, I think, of doing it from here, so that's 1 and 2. Notice it's going to save this equation to F4. So if you actually do insert a graph, you'll be able to plot this on F4. So let's go OK, and there it is again. So look, M is 0.73889, the B is 3.91. Go back to your graph, look, 0.73889 and 3.91. So the same numbers, same. But the benefit of having this page is that you get the R value and you get the R squared value. So R, correlation coefficient, strong, positive, and then R squared is literally just R times by itself. And again, the interpretation here is that 79.8% of the variability in the output can be explained by the input. So that means 21% of variation has to be explained by other factors. Fantastic. So we're nearly there. Down here, these residuals are quite interesting, but there's not a lot we can do from that menu page. Okay? But if we go to this page here, menu, analyze, residuals, show residual squares. Now, this is a pretty powerful menu because we've now got the sum of the square residuals is 60.05. So that's all of these areas added together. Now remember, the line of best fit tries to minimize the sum of all these areas. So if the line was a bit higher, if the line was a bit lower, this sum of squares wouldn't be at the minimum. Okay? So there's the sum of squares. Now this number here is used in a fancy formula to actually get this R squared value. So if I go doc, insert a notes page, then actually our formula for R squared, maybe I can type it in here. So our formula for R squared is also given by 1 minus SSres divided by SStot. Okay? Now, in this situation, our SSres, the sum of square residuals, is in fact this 60.05, sum of the square residuals. So the formula here would need to be then 1 minus 60 point, what was it? 0.5. 0.5? Yeah. But then we now need the SStot. But we can find SStot. Now we're going to get the SStot not from the graph. That was SSres, the sum of square residuals. If I go back to my spreadsheet, and then instead of linreg, I'm going to go to a different menu and a different function. So watch menu, statistics, stat calc, and it's 2 variable statistics. Now again, the 2 variable statistics menu is really only for linear regression. Now in here, this was 1 again, I think, wasn't it? 1 and 2. Boom. So look, this X bar is the average score for test 1. And this y bar is the average score for test 2. So all interesting, right? Here we've got the R value, which is the same from before. Here we've got quartiles and medians for test 1. Here we've got quartile and medians for test 2. So it's pretty comprehensive. And then lurking way at the bottom is SSY. And if you hover over SSY, can you see this beautiful little formula? Look, SSY equals sigma y minus y bar all squared. Okay, that's SStot. So now we're going to take this 297.7 and we're going to put it here. 297.7, right? Now, this is just a writing page. So if I copy this and go doc, insert calculator and paste, there is my R squared value using the beautiful formula. Close or not close, should we see? If I go cancel here, if I go all the way back up to linreg, here's my R squared value. I'm going to copy that. I'm going to paste it in. Those are my 2 R squared values. The bottom one is the automatic from the calculator. The top one is from using the formula, SSres, SStot. And we kind of rounded them, I think, to maybe 4 sig fig. What do you think of the accuracy? Almost identical to 3, 4, 5, 6 maybe. Yeah, 0.79829. So to 5 decimal places, they're both identical. And don't forget this top one here. The 60.05 came from our picture, which is over here. But look, there's more accuracy, 60.05467707, right? So if we used more accuracy there, and the SStot came from the number all the way down the bottom here. Let's see if there's more accuracy that we could have used. For sure, look, 297.73333333. So I'm pretty sure if we use the full accuracy, then we are going to get almost identical answers here. Boom. Now, how valid is it to use R squared in this situation?
We said it's valid because we use 2 different ways.
It's not valid because we use 2 different ways to confirm each other. It's valid because it's linear.
Oh, yeah.
It's valid because it's a polynomial model, right? And polynomial models include linear, quadratic, cubic, quartic, okay? Anything ax to the n, basically. Ax to the n with other bits and pieces. But this analysis with R squared isn't really valid for exponential maybe, logarithmic. There's a way to try and force it to be valid, but it's not so valid. Yeah, you might hit lucky and get a nice number. And remember, Luca, even if we use one formula and the calculator, they might agree. But remember, the other formula we used sometimes gives an incorrect answer. Okay, so I think the takeaway, certainly for exams, is valid to use R squared when it's polynomial models for sure. And the calculator method and the 1 minus SSres over SStot should give identical results because they are the same thing rearranged, basically, if you go through the maths and the proof. But these formula and R squared aren't the same thing when you analyse non-polynomial models. And we shouldn't really use R squared for those. I think that's going to be a blockbuster. What do you think?
If it even reported.